Thank you very much, Dr. Condithier. That was my Sopranos shirt you may have noticed up there, what Tony Soprano tended to wear. I'm very happy to be with you today and very thankful to be invited by Boehringer Ingelheim. I know many of you in the room and have met you again out here. I've had a very unusual career in that I've had much more association with the veterinarians of swine production than with economists. So I feel like I know you, and in my short presentation today, I want to encourage you that you will be the change, if there will be the change. Because you are the ones who are most intimate with the farm, you are the ones who have the confidence of the producer, you are the ones who are there most frequently. And so if we're to meet the challenge that was just mentioned, the 2050, and the challenge that I'm going to bring to you today, which I hope will upset the apple cart in the way that you see all of your work from this day forward. Because in that upset, you will have the ability to bring the kind of efficiency and that borders on and then blends into precision agriculture. And if you don't bring it, it will not come. Everyone knows about the FAO report expecting 2 billion more people by the year 2050 and 70% more food necessary to be produced. However, as an economist, I can tell you it's not more people that's going to bring the demand for more food. It's the ever-increasing per capita income, which has lit like a fire, especially through Asia and to many other parts of the world. And as people have more income, they move from very simple diets, mainly of grains, rough grains, and carbohydrates, into meat. And yet we're about ready to see a clash in the coming years between a ferocious increasing demand for food, often with different attributes than we're used to today, met with the challenge of producing it with scarce and more scarce as time goes on, global resources. And I will tell you that these resources will be allocated by price to those production units which are ready to take them in precision methods and bring value to the people of the world in quantities and in qualities which heretofore have not been seen. There's an innovation revolution that will be required. And as somebody who has studied Latin in my youth, I can tell you that the word innovation, like many of you will know, comes from the Latin word novus, new. But when you put the prefix in on there, innovation, it means not just to be a part of something that's new, but innovate means to be in the flow of the newness. And you must submerge yourself in the newness of the flow in order to bring the kind of precision, the efficiency, which will produce the revolution, not that is coming, but is already here. Let's talk about that a little bit, because production agriculture throughout the world is being transformed to a precision process. Now, that process has been going on for over 20 years in crop agriculture. But who would have guessed that the very technologies that we put in place during the 1980s and 1990s in developed countries throughout the world to raise pigs, and the tremendous benefit it brought in lowering cost and allowing massive additional production, would be like a brick wall barrier to the next step that we have to take as we move from current systems to precision systems. And the biggest reason is that the road to precision passes straight through the variance, or standard deviation. And in most modern systems today, not only is the variance in standard deviation not measured, it cannot be measured practically in batch systems. What system today measures daily feed intake except in the sow herd? Maybe in grow finish. What system today takes weights on every animal every day so that they know the progress of the growth curve and whether production has gotten off track? Not only is it not possible, it's not recommended, Because when you enter into the production process like that, you actually disturb the animals and bring down their ability to finish on time. Precision, though, as we know from the crop producers, brings about increased output with the same resources, or often with fewer resources, less waste, higher quality production, increased sustainability. And I want you, as we move through the rest of my talk, to open your mind to analogous thinking, because we're going to look at the innovation which has occurred in crop production as a way to think analogically about how that might come in to pork production. Well, not only will precision bring these great benefits and efficiency, but it will bring about a term that you may not have heard of, but is emerging now as we talk about the characteristics of production firms that will be successful in the future, and that is the attribute of economic resilience. Economic resilience is really the ability of the farm to quickly restore stability when a random shock, whether it originates with disease within the farm or from a change in government policy, the withdrawal of a subsidy and the crash of a market, the closing of an export market, whether it's by government policy or by disease. And when that shock wave hits the farm, those farms which are involved in low variance production will have a barrier and a kind of shield to allowing that variation to spin itself into their production or into their profitability. Because we know that variation in the production process works its way up inextricably into the profitability of the farm. And farms with high variance profitability not only have difficulty securing capital for the future, but also frequently are the ones which must give up and retire to those who are more steady. And so resilience makes possible the long-run goal, business goal, of your producers, and that is the achievement, really in the long term, of low variance, higher than average, industry average profitability. All right, let's begin our analogous thinking. I want you to think about what is the goal of irrigation of any crop. If we're irrigating a crop, what is the final goal that we're after? Well, it's to bring water or moisture to the root zone of the plant so it can grow. Well, there are many ways to do that, and as you can see from these examples, we not only can bring water to the root zone, but we can flood the field and bring it to many places in the field where it's really not needed or is in fact wasteful. We can use systems like this, which place on a warm day up to 40% of the water sprayed into the atmosphere instead of on the crop. These were the solutions in the California San Joaquin Valley, one of the most productive places on earth, when water was made freely available by the government. They brought it through viaducts and stuff from the northern part of the state and gave it to the farmers free. The farmer need only go out to the field and open the spigot, and water flowed through the fields. And so when an input is free, this is how we achieve the purpose. If you were to drive now from San Francisco to Los Angeles, and I encourage you to get to California, because so many people I meet only come to New York City and think it's the United States. You got to get out of that idea, okay? Get out of New York, come see the real people. But if you were to drive that highway, that 4 or 5 hour drive between Los Angeles and San Francisco today, and I did it because I had a daughter in San Francisco living and a son and grandkids in Los Angeles. The wife and I went to visit. This is what you would see today. Those same exact fields decimated and ruined because not only of drought, but because the government decided to turn off the water supply. You see, communities began to grow in Northern California and in Colorado and in the West, and they wanted the water back to support population growth. So this kind of shock coming to the system may have been preventable if the producers there had thought about moving to the next step, a precision approach to using water that achieves the purpose, which is moving the water to the root zone, but nowhere else. You see, we still achieve the production and the full productivity that we want, but notice that we don't place water where it's not needed. All right, turn on your thinking, because the problem in our business is that we've become blind to the variation that's weight variation, especially if it's in our business. We've fallen asleep, and we've fallen asleep because we only measure the mean. If you look at any metric that you judge your performance by on the farm, 99% of the time it will be the average value. Even though we know, for instance, in a closeout of pigs in a finishing barn, every single pig had a different average daily gain and a different feed efficiency. But we summarize that in one number. Or if I were to ask you, and I have already some of you, what is the weight at which your producer currently sells animals? And if you give me a number like 105 kilo or 110 kilo, what we know is, from myself over the last 10 years, looking at hundreds of millions of data points on marketed animals, that even if they're attempting and achieve what looks like a stable average weight, only about 17% of all the animals sold will be within a 10-kilo range around that target weight. And yet, the producer believes they're all going to market at the same weight. Of course, they'll admit that's not true when you challenge them, but when you ask them how many are not close to the mean, they'll always underestimate it. So we're going to start now realizing that we're working in a certain way against the natural process of the animal, which is to produce variation as a way to improve the species. However, our current batch systems of production, where we set the nutrition for the average animal, we set the temperature for the average animal, we set the ventilation for the average animal, I can tell you, you can probably go to your car, if you have a modern one, and find a different temperature setting possibility for the driver versus the passenger. So if we have 1,000 pigs in a building and we set a single temperature, how do we think that all of the animals will be comfortable? And that 30% or 40% that are relatively uncomfortable may not be eating what they should be. They may become sluggish, or they may be agitated and causing disruptions and so on. Humans, acting with the natural propensity of the animal to create variation, actually exacerbate the natural variation in the farm, either by not fulfilling what they know they should be doing, or even when they carry out the prescribed standard operating procedures for the farm. Again, because they're set not for individual animals, but for the average animal. Unfortunately, our technologies don't allow us yet to measure individual animal production, and so we're left often, in the U.S., no major farm ever weighs an animal, really, throughout the entire production process. They wait for the slaughterhouse to deliver the outcome of their production in receipts or kill sheets. And so you have to wait to the end and say, well, how did we do? Oh, well, better luck next time, right? But being able to intervene while the production process is still in progress and steer it back toward the direction you want it to go is a critical principle of precision establishment. Finally, we get these summarized kill sheets or closeouts of the group as a deceptive kind of representation in the average of the performance of all the animals in the group. And we know that the economic damage which emerges in high variance outcomes with our current technology is very difficult to detect and even more difficult to remediate. Now, as we move into the next set of slides, I want you to particularly concentrate on the success that's been achieved really in the 4 principles of precision agriculture and crops, and I want you to think about how that might be applied and brought to animal production. First of all, a precision approach uses technology to see things that the producer themselves could never see with their own eyes. So if you plant a 100-hectare field, there is no way possible that you could walk around the field or through the field and have a good knowledge of exactly what's happening. But if you look at satellite pictures of your field, often with infrared photography, which is made available to today's current crop producers, and you put that in GIS layered maps that have the elevation levels in the field and perhaps last year's production performance, suddenly with the aid of computers embedded in the tractors and in the implements which are used for production, when you discover a problem like this, there's no longer the need, which was the past, to simply put on an average additional side dress evenly across the whole field. But with a map of these exact locations, the computer and the equipment being brought over the field on the fly drops the corrective amount into the place where it's likely to do the most benefit. So if we bring that over now to the pigs, we say, what key processes really are hidden from you that if you could see them, you would actually make better quality decisions, right? Well, let me seed your imagination with this. We first discussed this in the understanding of selecting the optimal marketing weight. But what we found out was that the economic optimums for a farm are very different if you calculate them for a single representative pig, like the average pig in the barn, or you calculate them based on the distribution of weights that you're bringing to market, for instance, say in a truckload. Let me show you how that works. In most slaughterhouses, even if they're not explicit with this, but many of them are, they have a pricing scheme which over a certain weight of pig will give you the market price, but as the pig gets heavier, you begin to get discounts, and if they get too heavy, they become almost without value in modern slaughterhouse usage. So I guarantee you, if you ask now pretty much any producer to say, where is the weight which is likely to achieve the best outcome for me, what do you think they'll say? Where will they draw the line? Right here, right? We want to get as heavy as possible, but not get a discounted pig. The problem is, of course, that works beautifully for an individual pig, but what if I have 200 pigs on the truck and they have in the weight range span on them a 15 to 20 kilo range? Then we're talking about a distribution. And notice what happens when I, in my calculation in my spreadsheet, calculate the optimal weight to sell the pig, and now I bring a distribution with an average weight equal to that. Do you see what happens here? Lots of pigs will be discounted. And so the solution is we have to pull the average weight back compared to the single pig to optimize a group of pigs of variable weight. And that is the measure of the inefficiency or the imprecision of distributional marketing. And the wider that distribution is because of improper conditions on the farm and so forth, the more loss there is for the farm. Let's take a look at average daily gain as understood by a production person. Let's say a disease like PRRS comes to the herd and we're expecting maybe a 10% drop in average daily gain. This is how it's characterized by people on the farm. We go from all of the animals at 850, basically. This is the reduction of complexity mindset. Now they're all growing at 725 grams. But what actually happens in the farm? Well, we know that if the mean is 850, the animals typically have a distribution of growth patterns that look something like this, right? And if it falls then from 850 to 725, not only does that distribution slide to the left, but it may in fact change shape. And if some of the pigs are more severely affected by disease than others, it's very likely that in the barn, subpopulations of pigs are emerging in that distribution. Now, I want to ask you, do you think that calculating the loss associated with that average daily gain by calculating it for a single pig going from 850 to 725 and multiplying it by 1,000 will give you the same answer in terms of cost of calculating it based on how the distribution and shape changes? I can tell you, just like the marketing problem, the use of single pig thinking in calculating costs systematically underestimates the cost, particularly of disease. So rather than all the pigs moving back like that, this is what actually happens, right? They spread back in a distributional form and in these subpopulations, and these not only especially decrease their feed conversion because of high maintenance requirements and little growth, but they also lead to asset inefficiency in the building by slowing the turn of the building and keeping either the building from being marketed on time, or if they're forced out, they wind up producing less throughput and less value. So, think about it. The road to precision goes through the variance. We've got to begin to see the world as distributions and get rid of our single pig thinking. And even though we may not have the exact data to be able to do it, we need to begin modeling what we're doing on the farm and the decisions we make as distributions and gradually move our thinking away from single pig calculations. Secondly, a characteristic of precision agriculture is to match the input requirements to the current requirements of the farm, the exact current requirements. So imagine this as a finishing floor of the future, and we're able to see pigs and understand where they are and how to correct them over time as they emerge, as variance from plan emerges. Another characteristic of production agriculture or precision agriculture is to measure the progress of production and detect variance from plan as it occurs. Thousands of drones are flying across the fields of Europe and Brazil and central United States, measuring the progress of production so that we don't have to wait to the end and see what happens and then say, well, better luck next year, or better luck with the next turn of the building. So by collecting data and doing simulations, even when we don't have the data, it will lead to aha moments and make for better thinking and better improved solutions when we move from this single pig to distributional thinking. And then to be able to apply, lastly, corrections in near real time is a hallmark. So we want to do things like adjust nutrition more precisely to match the requirements of the pig, to reduce waste, and to reduce the metabolic load on the animal from either systematic overfeeding or underfeeding because we set one diet for every animal in the barn. We want to recognize that treatments, when they don't have to be applied to every animal and can be selectively applied to those animals that need it, are more effective and not only more cost effective, but use less scarce global resources. And then by looking and being able to see variation as it emerges, to be able to reorganize the harvest of the farm to maximize its value. So in summary today, I hope what you've seen has made you believe that how you're looking at the farm now, if you're thinking in single pig terms, needs a revolution in order to bring value to your producer clients. Because if you don't bring it, nobody will. Following John Dean and many others, we know that beyond the natural variation which is built into the animal, disease is the greatest cause of profit decline and valuation. And so we end by saying prevention really is the foundation upon which precision can be built, because it establishes a baseline of stability upon which other precision methods can be made. And precision then is not an option or a piece of technique in your tool bag, but I want to tell you today that I honestly believe it is the only future that leads to long-term, low variance, higher than industry average profitability. Thank you very much.